Okay, so just now we have conducted open circuit test and short circuit test on three-phase alternator. Now we will conduct the last test on the alternator, that is ZPF test. Now in order to carry out this ZPF test, we have connected three-phase star connected purely inductive load. So this is the three-phase star connected inductive load. So here this R2, Y2, B2 is shorted, so that is that makes star point, and then this RYB. This RYB of the alternator armature terminals, these are connected to RYB of the star connected inductive load. RYB of the star connected purely inductive load. So in this way, the star connected purely inductive load is connected across star connected armature of the alternator. Okay. Now what we want to do, again we will start the DC shunt motor, that is prime mover, with the help of this 3-point starter. Then adjust the speed to 1500 rpm, that is rated. Then we will switch on the excitation, that is DC2 supply, and increase this excitation till we get the rated voltage. At that time, initially the inductive load is low, so that the load current which we will get is less. Then we will increase this load current till we are getting the rated current of 4.17 ampere, and corresponding to that we have to generate the terminal voltage of 230 volt by adjusting the excitation current, as well as for speed we can adjust the rheostat in the armature and field circuit of the DC shunt motor. Okay, so we will proceed. First we will switch on the DC shunt motor. So I will switch on DC 1, that is DC supply 1, so as to start the DC shunt motor. So DC shunt motor is started. Now we will adjust its speed to 1500 rpm, 1500. Rated speed is to be adjusted. So right now it is 1330. Now we will switch on the DC excitation. So DC2 supply I will switch on. So excitation will be made on. So excitation is made on. So see, this initially excitation current is very small, 0.5 ampere. Now I will increase this excitation current, so that, see, initially load current is also very small. Load current is 0.5 ampere. Now I will increase this excitation. Load current is also increasing, and the generated voltage is also increasing. I have to make this voltage to 230 volt. Speed कमी झाला, speed वाढव. बस. This is now 160. Voltage is 160. 3 ampere. This is 200, 3.3, speed bar. Now I will increase this load current 3.5, 3.6. You have to go to rated. 9. Hi, कमी करू का? कमी कर. Now this is 3.7, 3.8, but the speed is now how much? 1696. Okay. कमी कर. So we can note down this reading. This is 3.85. See. Oh.
Please reduce the speed.
Okay, madam. This is 4 ampere now, corresponding to 4 ampere, corresponding to this 3.9 ampere. See, now I will increase this current further. This is now, voltage is 190 volts, 4.17. So this is now 200 volts, corresponding to 200 volts. थोड़ा स्पीड वाढवायला पाहिजे सर, थोड़ा स्पीड वाढवायचं. This is now 4.
Okay, fine.
Okay. Now this current I will increase. This is 3.8. Corresponding to 3.8, the voltage I am getting. So see, this is 4 ampere, corresponding to 4 ampere. I am getting 3.9. Here I am getting the voltage. 200 volts, almost 4 ampere and 200 volts. 4 ampere, 200 volts. बंद कर. हो, किती? 4 ampere, 200 volts, and corresponding to field current was 1 ampere. 1 ampere. So in this way, what we have done, instead of getting the rated voltage of 230, we can achieve a rated voltage of 200 volt, corresponding to current of 4 ampere, for which the excitation current we got 1 ampere. So this will be the probably the second last point on the ZPF curve. Of course, the topmost point on the ZPF curve will be corresponding to rated voltage of 230 volt, for which the rated current will be 4.17. So we are getting this particular reading 1 point lower on the ZPF curve. Doesn't matter, because ultimately instead of getting the topmost point on the ZPF curve, we are achieving the second last point on the ZPF curve. So that is also okay, doesn't matter. So in this way, we have completed the last test, that is the ZPF test on the alternator. Now by using the data of this observation table of OC test, SC test and ZPF test, we can calculate the voltage regulation of alternator by two methods: analytical method as well as graphical method, that is the phasor diagram method, for 0.8 PF lag, 0.8 PF lead and unity power factor. Okay, so thank you.
Thank you.